For this video, I will use this document as a reference material. This document explains the detail related to hardware modification and FSP stack configuration for low power mode. In this video, we will use an ammeter to measure power consumption. So according to this document, we need to remove R3 and connect male header on CN30. This red box indicates the location of CN30. Further in this document, you can find the setting related to BSP tab, clock setting and low power mode stack setting. In BSP tab, we need to select low power mode 2 option for sub clock drive. In the informative section, it is mentioned that why we need to select low power mode 2 option. In section 3.3, this document explains why we need to select subclock or loco option for TML-FITL0 source. This setting will supply a clock signal to TML 32-bit low power timer. Open ESK Studio, then click on this file icon, then select new, then select Renesas C++, then select Renesas RA project. A new dialog box will appear. You can give name to your project here. I am naming this project as low power mode. Now click on this next button. Here select FPB-RA0E1 board from this drop down menu. After board selection, click on next button. Here select none option, then again click on next button. Here select executable and no autos option, then click on next button. Here select bare metal minimal and click on next button. Now IDE will take some time to load your project. After project creation, open FSP configuration file. In FSP configuration file, open stack tab, then click on new stack, then click on power, then select low power mode stack. Now again click on new stack, then click on input, then click on external IRQ stack. Now click on BSP tab. In properties window, scroll down to find sub clock drive option. In this option, select low power mode 2. Now click on clock tab. For TML-FITL source, select loco option. Now click on pin tab, then click on manage configuration. We need to import low power mode pin configuration. We will provide this pin configuration file with this project. Locate and import this pin configuration file in ESK Studio. Now select the configuration file and click on finish button. Now double click on your low power pin configuration to make it as current pin configuration. Also you can remove other two pin configurations. Now expand P2 and check the setting for P200. It is already configured as external IRQ. Now open stack tab, then click on low power mode stack, then open properties window. Now expand general tab. For low power mode, select software standby mode. Now expand deep sleep and standby option, then expand wake up sources. Now select IRQ0 as a wake up source. Now click on external IRQ stack, then open properties window. Now for trigger source, select falling edge. Now you can define the callback function for external interrupt IRQ. Now we don't need to change anything further. Click on generate project content, then click on proceed button. Now expand src folder, then open hallentry.c file. Now expand developer assistant tab, then expand external IRQ stack. From external IRQ stack, drag and drop external IRQ open function call in hallentry.c file. Now declare FSB error variable. Use assert function to make sure external IRQ open function call was successful. Now from developer assistant tab, drag and drop external IRQ enable function call in hallentry.c file. Now use assert function to make sure external IRQ enable function call was successful. Now from developer assistant tab, drag and drop callback function for external interrupt IRQ. Now I will declare a flag variable. I can set this flag variable to 1 when interrupt was received. In callback function, I will set this flag variable to 1. Now we can use this flag variable in our main function. You can also declare this variable as volatile to exclude this variable from compiler optimization. Now from Developer Assistant tab, drag and drop low power mode open function call in hallentry.c file. Then use assert function to make sure open function call was successful. Now from Developer Assistant tab, drag and drop low power mode enter function call in hallentry.c file. Now use assert function to make sure low power mode enter function call was successful. Now declare while one loop here. In while loop, we will be checking the interrupt receive variable flag. Now use if statement to check if the interrupt receive variable flag is set to 1. Now introduce 3-second delay by using RBSB software delay function code. For first argument we can use 3000. For second argument we can use BSP delay units 2 milliseconds. Now we can reset the interrupt received variable flag to 0. Now we can again put RA0 board to sleep by using low power mode enter function code. After that, click on your project name, then click on this hammer icon to build your project. Now right click on your project name, then select debug as, then select Renesas GDB hardware debugging. Now click on switch button to switch to debug perspective. In debug perspective, click on this resume button twice. Now program is uploaded on board. Click on terminate button to stop debug session. As debug session is active, processor will consume more power. After terminate button is pressed, disconnect USB-C cable, then connect it again. In hardware demonstration video, you can observe that when board power up, it will enter in low power mode and consume 0.7 microamperes. When user switch is pressed for 3 seconds, board will consume 2.5 milliampere current in normal mode. Then it will enter in software standby mode again and consume 0.7 microampere current.